So this short video now is on maintaining your K-Control. How do you look after the K-Control? How do you make sure that the investment that you've put into this equipment is going to be maintained and it's going to give you your return? There are effectively 5 elements to the system, and those 5 elements will need different levels of maintenance than each other. Okay, so what are those 5 elements? Let's start at the center of the machine. So the radios, the through arm cable which goes along the arm, the slipring, the thermocouples, and the software. If you've got a K-Control that's integrated into your machine, then that software is going to go into 2 branches. One is going to be the 493K's K-Cord software, which you can install on a laptop. And the other one is the machine integration software, which will be installed on the machine that you have and is the responsibility of the machinery supplier. Okay. So the first thing, the radios in the center of the arms. You'll have 1 radio for each arm that you have K-Control installed on. The batteries will need changed monthly. Monthly is a good time to change your batteries. On the first day of every month, change the batteries. They may last you longer. And if you want to keep the batteries going until they're completely dead, you can do that. Your machine integration software should flag up that the batteries are getting low. The K-Cord software will also flag up that the batteries are getting low. The batteries are 2D cells. They're easily changed. You need to go into the center of the machine, take the cap off and put the batteries in. Just make sure the positive end of the battery is pointing out towards the cap. After you've put the batteries in, just make sure that the unit is in fact switched on. How else do you maintain the radios? There's not really an awful lot you need to do. Make sure there's no water on them. Make sure they're not too close to the oven when they come around, that they don't get melted. If you're switching them on and off at the end of each shift, maybe you shut down at 5 o'clock every day, I would advise you go around and switch them off. You can leave them on and they'll continue to operate quite happily. If you switch the machine off and the machine is powering the receiver, then the receiver will switch off. If the receiver switches off, then your transmitters go into a search mode where they're looking for that receiver, and that is quite hard on the power consumption. So your batteries would, you would use your batteries up a lot quicker in that instance. So either switch your transmitter completely off or keep your transmitters and your receiver on. There's not really an awful lot you can do to maintain those radios. You could consider getting a spare electronics top for stock, so that if one of them gets broken or damaged, usually damaged by somebody up working around them, dropping a heavy hammer or something, then at least you'll have an item in stock that you can swap over. 4 screws, take the lid off, and then the new one can go on top. You may need to change a small integrated circuit inside that replacement, just so that the system knows that that is arm 1, 2, 3, or 4. Okay, so that's the maintenance of the radios. Now the maintenance of the actual cable that goes from the radio to the slip ring. That cable is not moving, so it should not see any kind of degradation. Where you often find that that cable needs replaced is when there has been a crash, an accident, a fork truck, a mold, something hits the cable and breaks the cable in half, and then you need to change the entire cable. It's good to have spare cables in stock for instances like that. I would recommend that cable, that 6mm 1/4 inch thick cable, is contained within pipework, flexible pipework or solid pipework, it doesn't matter, just to keep the full force of the oven off that cable. Okay, it's an electrical cable, and we can't insulate those cables with PVC or plastic. It's going to melt in the oven, so we insulate them with glass fibre. We put PTFE lap around them to seal them, which is perfect insulation. The problem is it doesn't like to move. When it moves, the insulation breaks down. If there's water spray on it, it will break down. So, excuse me. So that's why it's important to ensure that that cable is completely sealed within the pipework. Okay. At the end of the cable, we get to the slip rings themselves. In terms of maintaining the slip rings, there's a few very important things that you need to do, and if you fail to do these, it could end up in catastrophic failure of the system, where we can't repair it because it's been mangled. And the most important thing you can do on your slip ring is ensure that the bracketing that go from the stationary plate underneath the slip ring to the arm, make sure that that bracketing is all tight. Those nuts and bolts are tight, that there's no movement. That stationary plate that sits underneath the slip ring, which is rotating, that stationary plate needs to be parallel with the rotating plate. We don't want anything like this happening, otherwise when it rotates it'll crash into the stationary plate, ripping out the inside of the slip ring and destroying it. And we have seen this happen on a few occasions where forklift trucks have come in to lift off spiders, but they've lifted off the slip ring, they've bent the slip ring, and because they weren't checked and readjusted, then when the machine started up, things started to turn and broke, and there was a crash. So those right angle brackets, check those. If you haven't done that since the system has been installed, I would strongly recommend that you hit the pause button, go down and make sure that all your nuts and bolts are tight around the slip ring. You can also check the gap between the stationary plate and the rotary slip ring. There should be spacers supplied just so that you know the correct spacing. You can check that just by touching it with your hand. The stationary plate should be level with the side bar the whole way around. Okay, not up inside or down below, so it should just be level the whole way around, and that's a good check. It doesn't have to be millimeter accurate because the brushes are spring loaded and they will move to accommodate any variation in that stationary plate being out of kilt. Okay, so we've got slip ring, nuts and bolts. We also want to make sure that the brush box itself is in good condition. Okay, so drop the 4 screws that hold the half moon lid onto the brush box. The brush box is the item that sits below the slip ring. Drop that lid off and look inside. Make sure that the brushes are moving freely. You can pull them a little bit, just a few millimeters, to break the contact between the brush and the slip ring. You can pull that down a little bit and that will just let you know that the springs are good. Make sure that the wires haven't been bent, because they're moving constantly as the slip ring moves around. Make sure they haven't been bent and they're not touching the side wall of the slip ring where they could rub against something that's moving, even rubbing against the lid of the brush box. Okay. You could drop the actual brush plate out and look at the underside of the brushes, just to see what the wear is like on the brushes. We find that the brushes, depending on how often you use them, can last you up to 8 months. We have customers that every 6 months, whether they need replaced or not, they change those brushes. We've got customers that have lasted over a year, but they're perhaps not running at full 24-hour, 7 days a week use. The temperature of the oven will also impact the rate of wear of those brushes as well. Okay, so brushes, brush holders, the springs. If you change the brushes, the springs will be replaced as well. There are springs that are on the brush holder, and it needs to be floating. So we want to check that those springs are also still in good condition. Okay. So we've got radios, we've got through-arm cable, we've got slip ring, we've got brushes, thermocouples. Thermocouples in a stationary scenario will last a lifetime. You connect a thermocouple to a control box and put it into an oven, fix it, that's perfectly fine. It will last for a lifetime. They will only perhaps need to be replaced if they get hit or the cable breaks down. In rotational moulding, where we're measuring the mould temperature, it's a completely different scenario, and there's a number of things that make what we're trying to do here very difficult, and that's why this is a really high cost thermometer. Okay. So thermocouples. Thermocouples are moving. When you come from your slip ring up to the mould itself, they will be, so we've got a mould, not a very good, well-shaped mould, and we've got the slip ring, we've got where we plug our thermocouples in, and then we've got our slip ring, our thermocouple coming up to here. Well, the more this slip ring moves, the more it moves during the rotation, during removing it from the mould, plugging it in, the lower the lifespan will be of that thermocouple. So that's why it's important that when plugged in here, they should be at least, they should come up and be strapped to perhaps some framework and then into the mould. So we minimise the amount of flexibility. These thermocouples are very robust, and they shouldn't suffer too much from movement. We've put a metal sheath around them, and the thermocouple is actually inside the metal sheath. So as the metal sheath moves, the thermocouple is given a little bit of flexibility. The main areas of breakage of the thermocouple is where the wire joins the solid sheathed probe, which goes into the mould. So this is where we normally break them at the connection, and this is where we normally break them in here at the connection. I say normally, this is where we would see them break if they did break. We do not have too many problems with these thermocouples because they've evolved so dramatically over the years. When you're pulling a thermocouple out of the slip ring, don't pull it by the cord, but pull it by the handle that will be on the slip ring. And if you don't have a handle on, or sorry, not on the slip ring, the handle on the thermocouple. If you don't have a handle on the thermocouple, get something on. We can supply small handles for the plugs. Up here, they also come with a handle as well. Looks something like this, with a hole in it. Forgive my bad engineering drawings, but that's some. You can also get a few fingers in there to pull that out of the mould. How do we attach the thermocouple to the mould? There's 1,001 ways to do that. Everybody's going to be different, and that we can probably talk about that in another video. So these are robust thermocouples. These are production thermocouples. You can go to a local catalogue and you'll get a thermocouple there for a fraction of the price. You'll be replacing them every few cycles. There's no doubt about that. But please try it and see what you think. If you find something that works well, let me know. So thermocouples can be the weak link if they move and if they're mishandled by pulling here or here at the handle or the probe. So we've got human intervention. We want to try and minimize that as much as we can. So if your guys are pulling these thermocouples in and out every cycle, try and get something automatic for them. Excuse me, like some kind of an over-center clamp that when you open the clamp, it pulls the probe out, or spring-loaded probes, or if you can, if you're molding something which is just single wall, you can just have your metal mold wall here, and if your plastic is here, yeah, and this is the inside and this is the outside of the mold, you can just bring a probe up and measure the mold wall temperature, or maybe a little bit of a dimple in to the plastic, and if you calibrate that or correlate that with the internal air temperature, that will adjust automatically the cycle for changes in ambient air temperatures, changes in mold wall temperatures, and so on. That there means your operators excuse me, your operators don't need to then pull these out every time, because it's not interfering with the plastic part. Okay. So what else can we say about thermocouples? If you have your thermocouples going into your vent pipe, then you've got lots of movement as well. So if the vent pipe is the only place that you can put your thermocouples, at least secure them to the vent pipe itself, and make it more difficult for the operators to flex those cables. Okay. So we're down now. We've done the radio. We've done the through arm cable. We've done the maintenance of the slip rings. Oh, there's one more thing I want to say on the slip rings. Whenever you are using a lot of powder and there's a lot of powder spilling inside the oven, what may happen is you get some of that powder getting inside the slip ring and making the rings dirty. So if you're lying on your back and you're looking up at the slip ring, you'll get a view of your slip ring. You'll have a brush box that we were talking about earlier, and then you'll have this little access hatch, which is a flat plate on the slip ring. Okay. If you open that slip ring up, if you open that hatch up, then you'll see the 4 slip rings that come all the way around the ring. Okay, and it is those 4 slip rings that your 4 brushes in here are touching. So if you have 4 slip rings, then you're going to have 4 brushes touching those slip rings here. Okay, those slip rings can become dirty. You might get the occasional speck of dirt on them. They shouldn't oxidize in the heat. That's what they're designed to avoid. But you can sometimes get them dirty. And what we do is we can take this off. We can put a fine sandpaper, abrasive paper in, very fine, and we can put it around a block and hold the block against that while we rotate the slip ring. So that is another point of maintenance on the slip ring. Another point of maintenance that you could use is to take the brush plate out and check the brushes aren't too worn down here, and if they are, again, on a fine plate of sandpaper, abrasive paper, just rub the brushes back and forward just to try and flatten those out a bit more. So that's maintenance up to the thermocouples. We'll have another short video on the next area of maintenance, which is the software machine integration. Thank you.